in the folder we've also got some PDFs which give these rules or these laws of Boolean simplification. Now part of your test is going to be simplification of Boolean expressions. So let's have a look at a few of them. We'll bring up here and I'm going to start with A and A equals. What does it equal? Well, I'm just going to use truth tables to prove it. So if I have A, the possible inputs are 0 and 1. And you can do this in an exam, and in fact I suggest you do them in an exam to make yourself fully aware of, prove to yourself what the simplifications are. So if A is 0, 1, then A and A, let's do 0, 0 gives a 0, 1 and 1 gives a 1. What's the same? So we can say A and A is just the same as A. In a similar way, let's do A or A equals, well, let's start with A. Again, two possibilities. A or A, 0 or 0 is 0, 1 or 1, we can say. It's pretty boring at the moment, nothing really happening. So let's now do A and 0. So A is 0 and 1 again. 0 column is just that. So let's do A and 0, and I'm going to prove to myself that it actually equals 0. 0 is 0, 0 and 0, sorry, it gives 0, 1 and 0, they've both got to be true, and they're not, so it's false. Now what we'll do here, what is A and 1? Now my conjecture is that it's A, alright, so A, 1, 0, 1 is the possibilities, 1, 1, so A and 1, if it's 0 and 1, it gives a 0, 1 and 1 gives a 1, and it's the same pattern as A, and therefore it's that. Let's go and have a look at A or 1. A, 1, 0, 1, 1, 1, and this time it's going to be A or 1. Now this actually simplifies to 0 or 1, only one of them has to be true. So that gives 1. 1 or 1 also gives 1. So A or 1 always gives a true output. It's a great way of cancelling out some terms in expressions. Alright, and the final one I'm going to do here just for now is, sorry, two more. So we'll do something like B or not B equals. What does B or not B equal? So there's not B. If it's a 0, it's a 1. If it's a 1, it's a 0. So what is B or not B? 0 or 1 gives 1. 1 or 0 gives 1. So that equals 1. On the same truth table, I'm going to do B and not B. So B and not B equals, let's have a look, 0 and 1 gives a 0, 1 and 0 gives a 0. Alright, so that's always going to give 0 as a response. Now those aren't, you don't need to remember every single one, you just need to be able to work it out. Be able to calculate, to create the truth table in an exam and work out what it is and then simplifying long expressions. And the final one I'm going to do, B or B and C. Now this is the absorption rule, and we're going to prove that it actually gives you B as a response. This is a great one because it gets rid of two logic gates and also gets rid of this term and just isolates the B on its own. So let's have a look. B, C, 0, 0, 0, 1, 1, 0, 1, 1. We need to know what B and C is, which is a 0, 0, 0, 1 column. So B or B and C. So we're using this column and or together. 0, 0 gives 0, 0, 1 gives 0, 1 or 0, because it's an OR gate, only one of them has to be true. 1 or 1 gives 1, and you can see that this column does indeed 0, 0, 1, 1, 0, 0, 1, 1. So we've proven the absorption law. Okay. So we've proven the absorption law, but I would do that in an examination. So let's now use some of those laws. I might bring that sheet back in a little bit, just so we can utilize it. But let's go and have a look at some of these now when doing some exam questions. So if I go back, this is the first one. It's on the same one as the truth tables, but it's on the next page. So I'm going to look at GCSE one, P and Q and P and Q. Now it's like mathematics. You can take a common factor out. It's actually called a distribution law. P and Q or not Q. Now what I mean by distribution is you've actually factorized on the opposite. But if you do P and Q or P and not Q, it's similar in doing A plus B. Similar to that, 3A plus 3B. PQ or P not Q. Same thing. So I've done that. Isolated P and Q or not Q. Now I've already done this on that particular one. P or not. Sorry, it's Q or not Q equals 1. So I know that that equals 1. P or 1. I would expect to see this in an exam, no? 0, 1, 1, 0. And then see this 1, 1. So I'd expect to see that, although it's not required. You may know all the laws off by heart, but I would expect to see that just for your peace of mind in an examination. P and 1 can be simplified to P, and I'd show that P and 1, 0, 1, 1, 1. P and 1, then therefore and together is 0, 1. It's the same as P. So there we are. There's my simplification. We got that. Now X or not X and Y is worked out slightly differently. Now what I'm going to do here is I'm going to do the distribution law again the other way round. So this time I'm going to do similar to if I had that in brackets. That's what we're really saying. So it's X or not X and X or Y. So X or not X, X or the Y. So X or not X, when I have a look at my rules, X or not X gives me 1. Again, utilize the right hand side if you need to. 1 and X or Y you can't simplify, right? But it's 1 and X or Y. Now X or Y and something is just X or Y. So X or Y is a term. You can write it like that, or you can write it X or Y and 1. But if I treat X or Y as one term, let's call it Z, 0, 1, and with 1, Z and 1, 0, 1. Well, it's the same as Z. So that just gives me X or Y. So the 1 goes. Alright, let's have a look at a few more GCSE ones. So P and 0 or P. Oh, it's got brackets there, so it's asking to use the distribution law. P and 0 or P and P. Now we know P and 0 equals P and 0 equals 0. And just look, P and P would be P. So I can use both of those there. P and 0 is equal to 0 or P. We haven't used A or 0 there, so I'm going to prove it here. What is 0 or P? P is a 0 or a 1. 0 would be always 0, of course. So we're going to do 0 or P or 0, same thing. 0, 1 or 0 would give 1. So what's it shortened to? It's just the P. So there's your response for that one. There's your answer. Now, much longer one here now. Multiply the brackets. Q, Q, or QP, or PQ, or PP. It's like in maths when you multiply brackets you end up with two terms, Q or Q, QP, PQ. So now I haven't told you this law. We can prove it via truth tables, but I'm not going to. You have a go yourself. QP is the same as PQ, so I'm just going to rewrite that as PQ or PQ or PP. Now Q and Q, we've already done this as a truth table. Here is the same as Q, and Q is the same as Q. P and P will be the same as P. So there we are. That is Q or P and Q or P and Q or P. Alright, now I can see that P and Q or P and Q is just two terms together. Alright, now I can either do the absorption rule twice, or I can get rid of one of these, but if you look at Q or P and Q, that's in the same format as the absorption law that I showed down here. Q or QP. Q or QP just gets simplified to Q. That's that one. And this one over here, P or P and Q, just gets simplified to Q, and that's it. Alright, or if you want to write it in alphabetical order, put it that way, but it's the same thing. Right, let's have a look at some others. Oh, so there's a few more now. Now these are actually taken from some AS exams, but it's the same. These ones are particularly at a similar level. Let's have a look at this. This looks fairly similar to one we've just done, in fact. AA or A and C, or CA, I'm going to write down as AC because it's the same thing, and then I'm going to write it as BC, not CB, but it's the same thing. AA is A, or A and C, or A and C, or B and C. A and C, via the absorption rule, just becomes A. B and C. I'm going to apply the absorption rule again here. That's A or B and C. I've got too many unlike terms, you know, A, B and C, and that's as far as you can go for that. And that's an AS paper. The next one, oh, there's a bit of work to do on this one, because there's negated or not terms here. So let's just have a look. A and not A, or A and B, that's multiplying out that first bracket, or CA, I'll write it AC or BC, that's this one here, and then finally not AB or not AC. Right, let's see what we get. A and not A. Again, I would probably write that out in an examination, but there we are. We know it's equal to 0. 0 or, we've got AB, AC, BC, not A and B. Oh, that's very similar to this here. Look at this. So what I'm going to do, I'm going to gather them up. Right, they're dealt with. Or, and I'd keep track, you know, I've dealt with that, I've dealt with that, I've dealt with that. AC, BC, oh, not AC. That's very similar to that one. So I'm going to do not A and C, and then I'm now going to have BC on the end. Unfortunately, I think BC is just going to be left out of it for quite some time. Naught or something. Naught or something. I haven't actually written it on there. It just cancels the naught. For example, let's go and have a look down here. A or naught. If A is 0 or 1, that's naught. What is A or naught? 0, 0, 0. 1 or 0, oh, it's 1. So A or naught is the same as A. A or 0 is the same as A. So in essence, I've done 0 or that is just the same as A, B, or not A, B, or AC, or A, C, or B, C. Just a point, if I don't write the and in, I'm assuming there's an and in there. So if I've done that on previous questions, there's an and there, I just haven't put the dot in place. Okay, right, now what I'm going to do now, I'm going to take a factor out of this, of B, and I'm going to leave in there A or not A. That's what the not A's are for, they're going to cancel each other out. Or for this one, I'm going to take C out, and I'm going to leave A or not A inside, and I'm going to leave the B, C here. Let's see what happens. A or not A. yeah, A or not A, similar to this one. A or not A is going to give you 1. So that's B and 1, or C and, same here, C and 1, or B and C. B and 1, well, I've done this already as well. B and 1 gave you this, just B. So A and 1 was A, so B and 1, it just gives B. So there's going to be B or C or B, C. Now it doesn't matter which way round I do it. I can bring the BC over here and do B or BC or C, or do C or that. In essence, the absorption law is going to work here to say B or, that's going to simplify down to C. Alright, that's the absorption law. A reminder, C and B we'll have here 0, 0, 0, 1, 1, 0, 1, 1. Make sure all possibilities are there. We'll do B and C 0, 0, 0, 1. We'll do C or BC, which is that there, odd. Oh, there's a 1 there, so that's a 1, 1, 1, gives that. The patterns for C and that are the same, so I've proven it, and therefore we're left with B or C. Look at the power there now, look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 logic gates reduced down to 1, and we've also got A out of there. If you did a truth table for that and a truth table for that, you'd find you get the same result. Right, and as we go over the page, there are some others to do. I'll pick one of these to have a go with. That one looks fairly similar, and there's a lot of cancellations out. This one, we'll have a go with this one. That looks like a not A there, and there's also 0, so let's go and see. There's probably a variety of rules to use in that. Again, there's brackets, so it wants you to multiply them out. Or A and naught, or A and not A, or B and 1, or B and C. So let's have a few looks here. So A and B, or A and C, or A and 0 just gives 0. Again, write the truth table out in the examination. Or A and not A, same as B and not B, that's also 0. Cancelling each other out. B and 1, however, same as A and not 1, is A, so B and 1 is equal to B or B, C. Now I'm sure you're screaming over at the video here that then is the absorption rule. So let's have A and B, or A and C, or 0 or 0, or that's just going to be B. Now the zeros we can't just remove, but that's in essence what's going to happen. Let's just go and have a look. Again, I missed that out, but I did it on the previous page, that something and 0, or something or 0 is 0. A or 0 gives 1, or 0 gives 1. So it's exactly the same as A. So we could do A and C with that. It would just give me A and C. And we can do A and C or 0 again. So it's A and B, or A and C, or B. Now I'm going to move B over to this side. So I've now got B or A and B, or A and C. And again, B or A and B, it's the absorption rule. Look for that because it's a very useful one. That gives B or A and C. And that's as far as you can go with that question. Okay, so well, we work through them. You don't have to write the rules down, but make sure you know how to write out the truth tables. Well, I'd say don't write the rules down unless your teachers in your particular school have asked you to do so. Now, a reminder that these are in cyfrifiad are there, logic and Boolean algebra, rules are there, there's also the questions are there, past paper questions. Have a go with them, comment on the video if you need to, assistance.